Okay, test equipment review time. Scope probes. In fact, some really cheap scope probes. I got these off eBay. $9 for a set of 200 megahertz probes with $3 shipping, which is an absurdly low price. This is the TP6100, rated for 100 megahertz. We'll take a look at these probes, see how they're made. We'll compare them to probes that cost a little bit more. So what's in the box? Obviously two scope probes, more importantly a little tool to compensate the probes, some colorful rings so you can identify the scope probe to be the right channel, and some protectors. Okay, so they're pretty standard construction. They have a spring gripper you can pop off if you want to manually probe, and of course sharp tip. A ground lead, fairly long, about 6 inches. Obviously that's going to ring quite a bit inductively if you're probing high-speed circuits. You can't detach it. And there is enough ring here that's conductive so you can put down a shorter ground return. Now, in the little accessories kit there is no little spring that you would see in a traditionally in a probe, but I guess you can make your own if you want to have a nice short path to the ground. Then of course there's just a standard compensation port on the back of the scope probe. So they sure feel legitimate, to be honest. They don't look like they're absolutely the bottom of the barrel. Okay, for comparison purposes, I'll use a Tektronix probe, the 6139A. This probe is for my TDS540 scope, a 500 megahertz probe. When new, these probes were around $400, and even today, actually, in used, they sell well into the mid-hundreds. So, clearly a much more expensive probe. Okay, before using any scope probe, of course, you have to compensate it, and there'll be a little hook in the front edge of the scope, and of course, the little adjustment tool. This is to achieve flat frequency response over all frequency ranges. And when it's nice and square, of course, you're in the right spot. Now what I'll do is I'll plug in the much more expensive Tektronix probe next to it, and I'll make sure it's compensated as well, because it's usually used in a different scope, and the compensation won't match either. Okay, a couple electrical tests. I'll do a test of the impulse response of the probe with a square wave, and then I'll feed it a nice fast sine wave to the limits of the scope I'm using. Now, probably the more stronger approach would be to use a RF signal generator and create a Bode plot or something on your spectrum analyzer, but if you're looking at a $5 scope probe, it's pretty likely you might have that kind of equipment. What I have here, though, is a very inexpensive signal generator, and it's just generating a 1 kilohertz square wave with relatively sharp edges. And I've got the two scope probes connected here, the cheap one here on the yellow channel and the Tektronix on the blue. Now, there appears to be only one trace because I've overlaid them to get some sense if they're responding the same. Let's move them apart here, of course. You can see there are two traces. And they're lining up really well, so this is starting to build some confidence that this probe is pretty good. Okay, what's here is a crystal oscillator. Has both the crystal and driver in it. A 100 megahertz square wave crystal, and also two scope probes connected to it. Again, sort of in the spirit of if you don't have a very fancy signal generator, obviously it's 100 megahertz. Now you can see that these two waveforms are different. Now they're offset in time, and that's because these scope probes have different electrical lengths, and that's not the most important thing. But you can see more importantly, the blue waveform is larger than the yellow waveform, which implies, of course, the 500 megahertz scope probe is passing more information than the very inexpensive one. So here we start to see some differences. Okay, so scope probes have been changed again. This is the Tektronix probe, and over here the probe that came with this scope. You can see they're quite close now. They're about the same, which tells me that the amplitude response of this inexpensive probe is different than the probe that came with the scope. Now, it's still quite usable, but I have my suspicions as to whether it's a true 100 megahertz probe. Okay, well, I'm not entirely sure these are 100 megahertz probes, but I'm, to be honest, far from upset. They actually performed reasonably well, and cheap probes always have a place in a lab, especially when you're doing measurements where you don't want to worry about damaging your probe. So, good stuff. Another curiosity in the test and measurement equipment you can get off eBay.